Hello everyone, welcome back to our YouTube channel. In this lecture, we will discuss some of the numerical problems from the chapter of electrostatic force and electrostatic potential. So the first question says like this: two charges Q and 2Q are placed at a distance x and x by 2 from the third charge 4Q. All the three charges are on the same straight line. The question says calculate Q in terms of small q such that the net force on 2Q is 0. So according to this question, suppose here is a charge capital Q, then somewhere here there is a charge 4Q. The distance of this capital Q from this 4Q is x. Then the distance of this 2Q from 4Q, it is x by 2. So that is somewhere here we have a charge 2Q. And this 2Q, it is at the distance x by 2 from 4Q. And also, the question says that all these three charges are on the same straight line. So, let us say they are lying on this line. Now, the question says calculate this capital Q in terms of small q such that the net force on 2Q is 0. Now, solution: let F1 be the force on 2Q due to capital Q. Say F1, it is in this direction, and let F2 be the force on 2Q due to 4Q. The force, say it is in this direction. From Coulomb's law, the magnitude of F1 is equal to 1 by 4 pi epsilon naught. Here the charge is capital Q, and another charge, it is 2Q, and the distance of this capital Q from this 2Q, it is also x by 2. So we have to divide by the square of the distance. So we have to write x by 2 holding square. So again, F2 is equal 1 by 4 pi epsilon naught. Then for F2, the charge it is 4Q, and another one, it is 2Q, and the distance of this 4Q from 2Q, it is also x by 2. According to question, it says that we have to calculate capital Q in terms of small q such that the net force on 2q is 0. Net force on this charge 2q equals 0 means F1 is equal F2. This implies that instead of F1, I can write 1 by 4 pi epsilon naught capital Q multiply 2q divide x by 2 holding square. This one, F2, is equal to 1 by 4 pi epsilon naught. So 4q multiply by 2q, the distance, it is x by 2 holding square. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught get cancelled, x by 2 holding square, x by 2 holding square, 2q will get cancelled. So this q is equal to 4q. So hence, this value in terms of small q is given by q equal 4q such that the force on this 2q is 0. Now, we will discuss this question number 2. The question says like this: two identical balls, each of mass 10 to the power minus 3 kg, carry identical charges and are suspended by two threads of equal length. At equilibrium, they position themselves as shown in figure. The question says, calculate the charge on a ball. So here it is given Q1 equal Q2, say equal Q. The mass of any one of the ball is equal to 10 to the power minus 3 kg. Remember one thing, the ball is in equilibrium under the action of three forces. Number one, tension in the thread. Number two, weight of the ball. Number three, Coulomb's repulsion force. So here, the tension of the thread is represented by this. The weight of the ball is always acting vertically downward, like this. The Coulomb repulsion force is in this direction. Now, the tension T is resolved into two components. One, it is along the vertical. So here, this angle is 45 degree. So therefore, along this vertical, we can write T sine 45 degree. And along the horizontal, this tension is T cos 45 degree. Since the ball is in equilibrium, from here we can write T sine 45 degree is equal to mg, and this T cos 45 degree, this is equal to F. Say this one is equation 1 and this one is equation 2. If we divide this equation 1 by this equation 2, we can write t sine 45 degree by t cos 45 degree. This is equal to mg divided by f. So t will get cancelled. So sine 45, it is 1 by root 2. Cos 45, it is also 1 by root 2. This is equal to mg divided by f. So 1 by root 2, 1 by root 2 will get cancelled. So this implies that f equal mg. But from Coulomb's law, this f is equal to 1 by 4 pi epsilon naught q1 multiply q2. But here q1 is q, q2 it is also q. So we can write q square divide by 0.2 holding square. So here the distance between these two balls is 0.2. So this is equal to mg. This value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. So q square, this one is equal to 10 to the power minus 3 kg. Then multiply by 9.8. This g is 9.8. Then multiply by 0.2 holding square. And this q we can write as 10 to the power minus 3 multiply 9.8, then 0.2, then divide by 9 into 10 to the power 9. So if we solve this numerical value, this q is equal to 0.208 into 10 to the power minus 6 coulomb. But 10 to the power minus 6 coulomb is equal to 1 microcoulomb. So this q is equal 0.208 microcoulomb. So the charge on any one of these two balls is 0.208 microcoulomb. Now we will solve this question number 3. So solution. The question says 2-point charges 4 microcoulomb and minus 1 microcoulomb are separated by a distance of 1 meter in air. So there are two charge. One, it is 4 microcoulomb, and the other, it is minus 1 microcoulomb. They are separated by a distance of 1 meter. The question says, at what points on the line joining the charges is the electric potential is 0. So let P be any point on a line joining between these two charges, 4 microcoulomb and minus 1 microcoulomb, which is at a distance x from 4 microcoulomb. So if the distance of this point P from 4 microcoulomb is x, so therefore the distance of this minus 1 microcoulomb from a point P, it will be 1 minus x. We have also discussed that the potential at any point which is at a distance r from a charge q is given by V equal 1 by 4 pi epsilon naught q divided by r. So here, let V1 be the potential at P due to 4 microcoulomb. Then V2 be the potential at P due to minus 1 microcoulomb. So if we use this formula, V1 is equal 1 by 4 pi epsilon naught. The charge is 4 microcoulomb. 4 microcoulomb means 4 into 10 to the power minus 6 divide by the distance of a point P from 4 microcoulomb, which is x. So V2 is equal to 1 by 4 pi epsilon naught. The charge, it is minus 1 microcoulomb. So microcoulomb means 10 to the power minus 6 divide by 1 minus x. Since the distance of this point P from minus 1 microcoulomb is 1 minus x. So the question says the electric potential is 0. So the net potential at P is V, which is equal to 0. This implies that V1 plus V2 is equal 0. So if we use these two equations, we can write 1 by 4 pi epsilon naught 4 into 10 to the power minus 6 divided by x, then minus 1 by 4 pi epsilon naught, then 10 to the power minus 6 divided by 1 minus x. So this is equal 0. So this implies that 1 by 4 pi epsilon naught 4 into 10 to the power minus 6 divided by x. This one is equal to 1 by 4 pi epsilon naught, then 10 to the power minus 6 divided by 1 minus x. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught get cancelled. 10 to the power minus 6 and 10 to the power minus 6 will get cancelled. So we will remain with 4 multiply 1 minus x. This one is equal x. So 4 into 1 is 4. Then 4x equal x. So if we solve the value of x from here, we will get x equal 4 by 5. So the unit it is meter. So for the net potential to be 0 at this point P must be at the distance of 4 by 5 meter from a charge of 4 microcoulomb. Now we will solve this question number 4. The question says, a test charge Q0 is moved without acceleration from A to C over the path shown in figure. The question says, calculate the potential difference between A and C. So as we can see from here, this electric field is uniform and it is denoted by a symbol E. Then the angle between this AB and this vertical line, it is 60 degree. We know that the potential difference between these 2 points is given by VB minus VA, which is equal to the integration from A to B, then E dot dl with minus. So from here, the angle between this AB and this electric field, it is equal to 90 plus 60 degree. So from here, we can write minus from A to B. So E dot dl is E, then dl, then cos. What is the angle between E and dl? So here we move a charge from A to B. So therefore the angle between this E and this dl on AB is 90 plus 60 degree. So this is equal to minus. So E is uniform as we can see from here. Then from A to B, then dl, then cos of 90 plus 60, it is nothing but minus sine of 60 degree. So minus minus become plus, so we'll get E. Then sine 60, it is root 3 by 2, and then integration from A to B dl. So this is equal to E root 3 by 2 multiply. Integration of this, we will get L, but that L is nothing but, it is AB. So let us mark this one as equation number 1. So also from figure, we can write cos of 30 degree, it is equal to AC divided by AB. AC divided by AB. So this is cos 30 degree. From this right angle triangle BCA, cos of 30 degree is equal AC by AB. So from here, we can write cos of 30 equal, instead of AC, I'll put by D. So this is AB. But cos of 30 degree, it is root 3 by 2. So this is equal D by AB. So this AB, it is equal to 2 divided by root 3 multiply D. So this is equation 2. So if we put this value of equation 2 in equation 1, we can write VB minus VA. This is equal to E root 3 divided by 2 multiply by 2 root 3 into d. So root 3 get cancel and 2 will get cancel. So we will write VB minus VA equal capital E multiply D. As we can see from here, BC is perpendicular to the electric field. So therefore, this potential at B is equal to the potential at C. Hence, the potential difference between 2 point A and C can be written as VC minus VA is equal to ED. So now, we will solve this question number 5. The question says like this. If a dielectric constant is inserted between the parallel plate capacitor, the capacitance changes from 10 microfarad to 50 microfarad. The question says, calculate the dielectric constant of the medium between the plates. So solution. So here it is given that the capacitance of a parallel plate capacitors in the absence of dielectric, say C naught is equal to 10 microfarad, and in the presence of dielectric, the capacitance is C equal 50 microfarad. As we have mentioned earlier in our previous lecture, that in the presence of dielectric, the capacitance C is equal to K times epsilon naught A divided by D. But this epsilon naught A divided by D is nothing but the capacitance in the absence of dielectric. So therefore, from here, if we want to calculate K, then we have to use this formula C by C naught. So here, this value of K is equal, instead of C, I'll put 50. Instead of C naught, I'll put 10. So this value of K is equal 5.